for coming. We're going to be talking today about microservices and monoliths and how you get from one to the other. How many people are doing microservices, would you say? Couple? Kind of? Yeah, it's kind of an ambiguously defined word nowadays. We're going to look at this through the lens of a fictitious organization, but it's based on my experiences personally and others that I've worked with at our customers at Red Hat. So my name is Christian Posta. I'm a chief architect at Red Hat. I work with our customers in mostly North America to help them figure out what this DevOps, microservices, cloud, all this stuff really means to them and how they get value out of it. Every 10 years or so, we get these new hype cycles about SOA and ESB and microservices and all this stuff, and I try to help make some sense of it. I did spend some time at a large internet company that now is considered a poster child for microservices, and I got to see the level of maturity, what it really means, the automation that they had in place, the way they built services, the way the teams worked with each other, and I try to help bring some of that experience to our enterprise customers. I've written a couple books, one microservices for Java developers, and another one that we're releasing here at Summit called Introducing Istio Service Mesh. Has anybody heard of Istio? If you could raise your hand. Oh, yes, all right. I'm a contributor to Istio and a bunch of other open source projects, and I like to write about these types of topics in various publications and my blog and so forth. And actually, this talk came from a series of blogs that I did in the past. This book that we're releasing will have printed copies for it down in the Red Hat booth down in the Partner Pavilion. And I think tomorrow at 3 o'clock, we'll be handing them out, and I'll be signing them and that kind of stuff. If you go to developers.redhat.com, you can get the electronic copy. All right, so let's get going. Low risk monolith to microservices. What does that mean? Low risk. Low risk means that there's uncertainty about what we're doing. When we make a deployment, when we make changes to our system, we hope and think that we know what the impacts are going to be, but sometimes they don't turn out the way that we think. And so the type of risk we're talking about here is in those uncertain times, what are the bad things that can happen? And what are the chances, what are the probabilities that those bad things happen? When we talk about monolith, we talk about and this is where things get kind of confusing, because having a service with all of its components co-located with each other isn't the type of monolith that I'm talking about. What I'm talking about is a service or an application that has been around for many years and has undergone many different waves of developers, internal, external, whatever, and the architecture has slowly devolved into what we have. Let's see if this fancy thing works here. It does. What we have over here, where you started off with, because nobody designs an application for this, right? We start off right here, but over time, the entropy in the system, the different developers, the deadlines that we have to hit, kind of helps push the application down this path so that it looks kind of like this. So this is what I'm talking about. The monolith this is what I'm talking about. Microservices is a highly distracting word that serves to confuse developers, architects, and leaders into believing that there is a utopian architecture. How many people agree with that? Okay, but so what I'm talking about specifically is it is an architectural optimization to increase the rate of change and the speed of change, to bringing new features, eliminating technical debt, and basically maintaining the system and doing that faster than you can possibly do with the monolith that we just defined. Because we can assert with high confidence, this This is a report, the State of the DevOps report from 2014, in fact. We can assert with confidence that high IT performance correlates very strongly with business outcomes, profitability, market share, and so on. In the 2015 report, we saw numbers like high-performing teams outperforming their lower-performing counterparts by being able to do deployments, 30 times more deployments. And developer or deployment lead time, 200, so going from commit to production 200 times faster. In 2017, we saw an interesting stat. We saw in 2017 that that number, I just showed you the 2015 number was 30, is now 46 more frequent deployments. But look what happened in 2016. We had 200 times more deployments. And also, we were able to go 440 times faster to get code commit to deployment, but in 2016, we were 2,500 times faster. So what we're seeing is the ability to go faster through adopting automation, container technology, automated testing and deployment pipelines and so on. We are closing the gap in some ways between the high performers and the low performers. It's still a pretty significant gap, but that gap is closing. But what we also see in these numbers is that the mean time to recovery and the change failure rates, those are still growing. Those distances are still growing. The high-performing teams are introducing fewer detrimental changes and are able to recover from them a lot faster. So they have a system in place to lower the risk of doing these types of changes. And that's what we're going to be looking at. Because we want to use this services architecture where it makes sense, right? We want to use this to speed up an organization's development capability. It's a ability to bring out new changes to customers and see if customers get any value from it, and quickly iterate and go through that loop. And the number of bad things that we can sort of limit or recover from quickly helps lower the risk of being able to do that. So this is our case study. Again, fictitious. This is not a real company. There actually is a real company called Ticketmaster, but what I'm talking about right here, this is fake. This is from a demo that we've used for, I don't know, like 10 years to introduce basic application architecture. If you go to that link, you can see the Ticketmaster example. And in this fictitious company, Ticketmaster, like literally has, this application has been around for 10 years, in multiple different phases and so on. But it perfectly plays the role of this is a monolith. This has evolved over many years. It's very complicated at times in different parts of the code base. And if we take the story a little further, you can see that different modules have just sort of become this morass of stuff. And there's no real clear architecture. Some pain in maintaining a monolith like this. Making changes to it, you have to coordinate with many, many different teams and understand what they're doing, what their changes are. And when you do make the changes, it's possible that that negatively affects parts of the code that you had no idea that it should have. You have low confidence. You end up jamming a bunch of changes in together and deploying them all together. And so when you do that, first of all, the changes that you made, you can't really understand which change had this positive impact that we were hoping for, or negative impact in some cases. Being able to understand how long basic things like how many people are doing continuous integration in this room? A handful. So continuous integration where you're continuously checking your changes in to a single trunk, basically. If you have these long-lived, typically what we do with these monoliths is take out long-lived branches, work on them independently for months, and then try to bring them back together. The time that it takes to reintegrate those things it could be infinite. It's undefined. We don't know until we actually start to do it. Development time can be slowed down because just bringing up a big gigantic code base in the IDE is painful. It forces specific technology decisions. When there might be new technology to take advantage to solve a problem, but the monolith, if you're going to be working on that code base, You're stuck with the technology decisions that have already been made. So when we start to experience this pain, and we have this, this problem, then it's worthy to look at a services architecture like microservices. When do we do microservices? Because it's about optimizing for speed. If you don't have that problem, then you don't take that optimization, right? We don't just do services all the time because that's the utopian architecture. That's what everybody's doing. That's what Uber did, so we're going to do it. You should ask yourself a very honest question. Is the application architecture the bottleneck for making changes? If it's not, then go figure out what is and improve that and then come back. We meet with some customers who are not there and who are prematurely optimizing for services architecture when really if they improved the automation of how they do their deployments would get them deploying a lot faster by itself, just improving the deployment pipeline. So you don't really need to have a complex architecture, services architecture to do that. Meanwhile, how do you break these things up? We've been talking about microservices for a solid 4 years now, I would say. And there's been some good discussion on this topic. How do you actually break things up? How many people have heard some of these discussions? Do one thing and do it well. What does that really mean to you? A single responsibility principle. These are good. Organize around nouns, I've heard people say. Organize around verbs. So which one is it? The smart endpoints and dumb pipes, do I not have that one in? That's another one, pretty useless one also. This reminds me of some of the same things we did about SOA, that we said about SOA. That if we just, you want loose coupling, all right? Services are autonomous. We said the same things back in, I think this was 2004, 2005. And you can see, you get these proclamations of what it should be, but no real meat on how to do it. So let's try that one more time. I've seen literature also around, identify modules, use domain-driven design. I think that's a pretty useful set of guidelines. Align to business capabilities. Update the old code to, break out these new APIs and update the old code to call these new APIs. And, it kind of looks something like this, where in your monolith, you identify the modules that you might be interested in breaking out into a service, and then you build that service around that API, and you update the existing code to call that instead of the co-located code. And you just keep going until you get to microservices, right? And this is generally good, I think, but it misses a lot of fidelity in that process and what you actually do. Because it's not that easy to find the modules and the boundaries in the monolith, first of all. Like we said, this thing has kind of fallen apart and into a general pool of shared constructs that individually, if you change something, could potentially break something else, right? There's a lot of tight coupling in the application code and in the database. That often gets overlooked, that the database has lots and lots of referential integrity and foreign key constraints, and the database itself has morphed over the years. That we can't just stop the app and update it to call the new API. We have to think about doing this as the applications are actually taking load, actually taking traffic. Because typically these monoliths are there, and they've been around so long because they provide some kind of value. So we can't just stop the world and expect to perform a microservices architecture. There will be ugly migration steps. This can't be wished away. You will have to incur at some time some technical debt to undo the technical debt you already have. This is I don't know. I haven't found a way around it. If you have, please let me know. And there's also going to be a point of diminishing returns where it doesn't make sense to rinse and repeat, where the monolith might actually stay around. I know there are definitely stories of people who have gotten rid of it and gone away from it completely, but even the Netflixes of the world, Netflix itself still has its old monolith. So there's probably a point of diminishing returns where it doesn't make sense to break any of the things out, right? We said this is about optimizing for speed and going faster, making deployments and changes faster. If you've gotten to the point where you can go faster, you don't have to continue to break things down. Now, the problems that we are going to encounter are we need to make sure we have some level of test coverage for our application. And this is probably the first part where people start to fall down. Oh, we don't have tests. I think, was it Michael Feathers, he calls legacy code that doesn't have tests. And so this is pretty important. If you're going to start to make changes to the way the monolith works, you're going to need some kind of safety net, some kind of regression suite to help with that. I would say consider Archillion for integration type testing. Has anybody heard of Archillion? It started off as a Java EE integration testing framework, but now has evolved into much more than that. It can do testing inside of Docker and Kubernetes. It can do consumer-driven contract-based testing. So it's expanded into a very powerful testing framework. I can't remember if on the slides here. So I do highly recommend the Michael Feathers Refactoring Legacy Code book. That shows you how to go into the monolith in the nastiest of monoliths and strategies for how to introduce tests. I think that being the number one step, focus some time on that so that you can more safely make changes to the monolith. Ideally, you want to tackle you want to squeeze all of the deployment pipeline, automation, these types of version configuration, configuration management, that kind of stuff. You want to squeeze as much of that out of the equation as possible. You want to have those in place, right? You want to get as much of that in place so that you really that your application really is the bottleneck here, and that once we start to tackle it, we're going to start to see the returns from that. So our monolith. In this case, our monolith is the Ticket Monster application, and it talks to this big nasty database. Traffic comes in, talks to the monolith because the monolith has a UI baked into it. How many people have the monoliths with the UI baked right into the application? And that's kind of how we built applications 10 years ago. And it was a perfectly fine way of doing it. But now, if you have that problem, we'll look at try to break that apart. So, if possible and if applicable, what we want to do is first start off by taking out the UI. That's an independent component to the architecture. We don't want to redeploy the UI every time we are redeploying changes to the back-end business logic. And so this starts to go toward like a layered architecture, but we're not going to go that far. But what we do here when we try to break it out is we don't touch the monolith at first. We leave the monolith as is, right? We try to touch it as little as possible. What we do here is actually take a copy of the UI code, the HTML, the JavaScript, the CSS, all that stuff, and we're going to pull it out. We're going to make a copy of it. And we're going to use our ability to control traffic into, to move traffic over to the new UI when we want to. And have that new UI just call back to the back-end monolith. So we're not making any changes. We're introducing a new service, and we're using a form of traffic control to route some traffic over to the new UI. This gives us the possibility to explore whether or not that new UI is going to perform properly, whether it behaves exactly the same way that we expect, and we can do that independent of any real request path, right? So we can do this in a dark launched kind of way, where we can send traffic that's not production traffic. Maybe it's testing traffic, or maybe it's, I don't know, non-paying customer traffic that we want to send this new path, and finally control it. Now, that's a very powerful technique. How many people are able to very finely control the traffic into their cluster and shape it into the different deployment units that we have here. How many people are able to do that today? A couple, kind of? Okay. This is very powerful, and I'm going to take a quick interlude to explain what I'm talking about here. In a traditional deployment, the way the Ticket Monster was deployed, what we would do is make a change, build the deployment package, and deploy it. So take down one application. Let's say we have 10 of the application servers. We'll take one application server down, deploy the new one, and bring it back up. And we'll continue to do that. We'll try to do sort of a rolling change to our instances. And basically we start and then we stop, or we stop when it's done, when all of them have been updated. Now, in that scenario, what we have is someone made a decision, we're going to make the code change, and then you went off and did it. What's more interesting is decoupling the concepts of doing a deployment from doing a release. And what I mean by that is when you do a deployment, so when we talk about continuous deployment, continuous delivery, continuous deployment, that kind of stuff, I often hear, well, there's so much red tape, bureaucracy, we can't actually make changes, somebody has to sign off. Deployment itself should be a non-event to the business. Developers should just be able to do deployments. Now, a deployment is taking the code and putting it into production, in your production environment, in your deployment environment. If you're running on Kubernetes or OpenShift, which you should, then that just means making a deployment into OpenShift. The nuance here is that a release is actually bringing traffic to that deployment. And if you can separate those things out, you can get more powerful strategies for making changes. So, for example, Facebook does deployments. Developers can click deploy all day long. Code gets into production. They can do smoke tests, and they can do dark testing and that kind of stuff. And in fact, a lot of changes that get deployed out in Facebook and any of those other big internet companies, they're in production for many, many months before people actually start seeing the effect of those changes. Because they're able to very finely control the traffic, which traffic goes to which deployments. And that decision to release, where you actually bring the traffic to the deployment, that becomes a business decision. Then you can, hopefully more confidently say, let's start to unroll this to different geographies, different user groups, different classes of users, different loyalty, whatever, however you want to classify them. You can start to more safely unroll that by doing the release. Does that make sense? Istio is a piece of infrastructure that allows you to separate out deployment and release. Now, people have either written their own frameworks. Facebook has their own frameworks. Some of the big internet companies have written this stuff from scratch. But Istio is application infrastructure for controlling, for doing more than this, but for controlling the traffic flow through our cluster, so that we can say, well, we want only 1% of the traffic to go to this new deployment, or we want only the gold or the non-paying customers to go to the new deployment. Istio is a service mesh, which is this infrastructure. How many people have heard of service mesh? Okay, awesome. And is this way of Istio lives in the data path, in the request path of the request coming through the system, kind of like this, and it exerts itself as a proxy. So these proxies live with the applications. Each application instance has its own proxy. All the traffic to the applications or from the applications goes through these proxies. And with the proxies in place, now we have the ability to control and shape the traffic in between the cluster. Okay, we'll come back to that. I'll try to show a demo of that. Meanwhile, let's say that we were able to introduce, split out that UI, and we were able to control the traffic. And we say, okay, this looks good in our testing. As we start to bring over users to start to do the release, we start to see that this looks good, everything's good. Now we can have all the traffic come through through this new once a deployment, now a fully released component. which is good, but let's get into something a little bit harder than just breaking out the UI. But we're going to see some of the same techniques for controlling traffic as we start to unroll the changes for the rest of the system. Let's say we want to introduce a new orders service. Let's say at Ticketmonster that the way orders are processed, that is a point of differentiation for them somehow, interacting with the different vendors and event coordinators and so on. That's a differentiator for them, and they want to iterate on that particular part of the code more quickly. So what we start to do is introduce this new service API. And we can see here, this takes no traffic. This is completely dark in our cluster, and we might do a deployment. This might just be a simple API, and doesn't implement anything. It might just be a simple API. I think Jez Humble and others call this the walking skeleton. Let's get a very simple structure of what the application might look like, and let's make sure we get all the CI/CD pipeline and automation built around it so that we can actually do a deployment. But what we're going to focus on here is the API. We're going to focus on the API and the boundary of what the new service should encompass. So a lot of times, this is probably going to be a rewrite from the existing monolith, unfortunately. In the one that I worked on, it was a Perl application. That was the monolith. And there was no chance we were going to reuse that Perl code. So we're probably going to rewrite it. You're going to ideally focus on the API surface and stub it out in such a way that you can share it with potential users, maybe the monolith here, and explore the API surface and see how well that fits. There's tooling that in the community. This particular tool right here, APICURIO, which allows you to visually design the API surface, and then use tooling. I don't know if I have a slide. Use tooling like a project called Hoverfly. Has anybody heard of Hoverfly? Or Microx or WireMock? Any of those? Anybody heard of those? Those are service virtualization tools that basically allow you to declaratively give the API behavior, but you don't actually implement anything. So you're giving it a couple of descriptor files that say, when I get hit at /API/order, then return this response, right? So you're mocking out the service. But you're mocking it out in such a way that it's actually a deployable. So you can introduce this into your walking skeleton and introduce this into your CI/CD pipeline and get this out there and let people interact with it and test it. And they give you feedback, and you can continue to iterate just without writing any code. This is not about writing code. It's about figuring out an ideal API between your services. As you continue, you might start to, if you agree on an API, you figure out what the implementation is really going to look like. And the unfortunate reality of this, when you're talking about a monolith, is that this implementation is going to use data and use constructs that are very similar sometimes to what's in the monolith. We're going to need to bootstrap this service somehow with some data. But we don't want to take the monolith's messy set of tables and foreign key relationships and that kind of thing. We want to build the right representation for our service. So we want to focus on our API and our data model and our domain model. Actually, I don't know if I have slides on domain-driven design, but this is where the domain-driven design stuff fits in. Has anybody heard of domain-driven design? Okay. This is where we don't want the influence of the monolith to erode what we're trying to do with our new service. So there's a handful of ways to do this. You could try to use, if the monolith already has some kind of API or some loose definition of an API, you could try to use that and have the new service call that. A lot of times, well, at least what we found was that the API is not at the right level. It's either too coarse-grained, specifically for the UI, because that's usually what it's serving, or it speaks a protocol that we don't want to talk, some kind of binary protocol or whatever. So if it works, if you do have an API and your new service can use it temporarily, then go for it. You could copy all the data out of the old database, out of the monolith database, into your new service. And that's not ideal either, because now you have to try to keep that up to date somehow. You could connect right up to the monolith and have a direct connection to that database, which in my experience, that's actually what we did. And it wasn't ideal, but this is the type of this is the type of nastiness that you're going to run into and you're going to need to solve somehow, if for only a moment in time to allow you to do this move, allow you to go in this direction. A new concept, or not terribly new, but if I had this at the time when we did this, I think we would have done this. So what if we could say, well, the new service talks to its database. It's got its own database, but it does have a view of what the old database had. So it has some of that data, and then we can shape that data in the way that we want to see it in our new service. What if we had a way of doing that? Now, you could write your own APIs. You could write your own code to do that. Grab the code out of the database, munge it up the way that you want to see it. That ends up being a lot of extra boilerplate, which is what we did. But what if we could virtualize this? What if we could say, focus on the domain model and the API of the new service and introduce a virtualization layer at the data layer and build the tables, build the relationships that we expect, and then actually tie in the old database with the new database. What if we could do that? Boilerplate data integration. I have some stories, but there's an open source project out there called Teiid. Anybody's heard of Teiid? Teiid was originally envisioned as a data federation platform for grabbing lots of disparate databases, regardless of what they are, and pulling them together so that you could write reports and queries against it. I'm not talking about that here. I'm talking about how can we use that virtualization engine, not the whole platform. We're not doing reporting here per se. What we're doing is we're introducing a virtualization layer that allows the application to write its code against the database that it wants, and for a moment in time, introduce the data that the monolith has, but not in that structure, in the structure that we wanted. So that allows us to evolve our code, to temporarily use this kind of yucky integration thing that we kind of need to do real quick, and then go forward and run the implementation of the new service. There's a project in Teiid called Teiid Spring Boot that allows us to do this very easily. Set up the POM, and from there set up the data sources that you'd end up using. And in Ticketmonster, well, we happen to use MySQL for both services, but Teiid doesn't care what the backend services are. You can mix and match databases. That's the virtualization engine that it has. And in code, what we do, instead of a bunch of queries and potential joins and stuff that we have to do in memory and shaping it the right way, what we do is we write an annotation, just for the Spring Boot thing, fits in the Spring Boot way of doing things. We write an annotation that creates that virtual table and pulls the data from the right sources and exposes them in the JPA objects in the structure that we expect and that we want. Right? You can kind of see that up here. But we're pulling from a legacy database and I guess only the legacy database here. I thought we're, I guess not. Do you see it? There should be an orders database, but maybe not. Maybe I pulled the wrong example. Oh well. But we're able to pull from multiple data sources that and then join up the results of those data sets into the structure that we want. Here's another example. In this case, here's our select. We're going to do a union on the orders database and the legacy database, which is in here. Oh, damn it. And so in this case, when we do selects, when we do queries, we want to get the data that's in our database and the monolith database in a certain structure. When we do inserts, we want inserts to go into our database. Right? So we can control where we're querying from. Ideally, from the monolith, you're only pulling, you're reading data out, and storing the new data inside of your own database. So meanwhile, we have this approach now, so we can start to link up an implementation with the with the appropriate data and with our own individual database. And we want to start to test that out. We want to see how well that works. And in this case, what we can do is introduce a new version of the monolith that, and this is we did something like this, but this might not always be an option, right? Sometimes changing the monolith is such a big pain in the ass. But in our case, we were able to start to introduce a new version that did call out to this orders service instead of its own internal logic. But again, we used the traffic shifting capabilities of whatever platform. But Istio would be a great fit for that, for being able to control how much of that traffic went to our new version. And what we did, since this was an actual orders system, would actually take orders. We didn't actually send real traffic. We mirrored the traffic. We took copies of the traffic and sent it to the system. So for a period of time, the transactions would come in, we would process them, and we would either just throw them away at the end, we wouldn't actually save them, or we would save them into our database, but the database was still kind of a dummy database anyway. We weren't taking live transactions. When we do the mirroring, when you do the mirroring, you can annotate the request and say, this is a mirrored copy. So do whatever you want with it. And our new deployment would actually write to the database and actually roll back. You can use the service itself to do this type of interaction, or you can introduce a more powerful gateway to control where that traffic is going, and potentially even all the way down. If the API is suitable and it fits with the UI, you can just have the gateway call the orders service directly. I'm kind of running short on time, so I was going to show a little bit more about this mirroring technique. Anybody able to do that? Do traffic shadowing in your clusters today? Okay, so it's a very powerful way of introducing a deployment into your production system, and have it take requests and watch and observe how it's behaving without it impacting any requests, any real requests, the request path. And with Istio, we can do that. We can shadow traffic from the main thread, the main request path, into a new cluster, into a new deployment. And we can do even more interesting things with a project called Diffy, which came out of Twitter, that actually will do a comparison. So it will take the mirrored traffic and call the old version, call the new version, and do a comparison of the results. And flag the ones that deviate too far from what the API should be. So a combination of Istio with Diffy allows you to get this very powerful deployment and release process that lowers the risk of making changes. I would like to kind of show a demo, and I only have a few minutes left. And what slide am I on? I've only got 5 left. Another interesting or appropriate way to bring changes into your system, into your monolith, is to make the changes. So for example, make the changes so that it will talk to the order service, but not enable that change. So you have all the code in there, do the deployment, and using feature flags, you can switch on when that behavior should be enabled. And I'm going to get to the demo. But if you have questions for that afterward, let me know. Ultimately, what we want to get to is a path where we don't use the virtualized database anymore. So again, we're taking on some technical debt to get us to a better spot, and then we gotta pay down that technical debt. And there's an interesting tool out there called Debezium.io. If you go there, that's a change data capture system that, once you're ready, allows you to virtualize the database, but actually materialize the data from the old database into your database, and then you can shut that stuff off. So now your database, so in combination with the request traffic coming in, if you shifted it over, you turn the feature flag to enable that feature. At the same time, you have your database disconnected from the production, or the monolith database, And now you've made it to, you got rid of your technical debt and you've got this independent service. Write lots of tests, use fine-grained traffic control, improve your CI/CD systems. That, get that top notch. Use technical debt. Don't be afraid to use technical debt when it makes sense, especially when ideally it's going to leave you in a better spot afterward. Don't take on the technical debt and then end the project right there. That's just going to put you in a worse situation. Have lots of good monitoring and figure out a way to lower the risk, either a combination of these tools and techniques, along with reducing your batch size, the size of changes that you're making into the system, and do them frequently. That's going to be an important part. The more you do it, I think what's the philosophy? If it hurts, do it more, right? Do it as frequently as you can to prove that you're able to do these releases, get changes out, and lower the risk of doing that. I have a quick demo, if you don't mind. So what we're going to look at here is we have our Ticket Monster application up. If I refresh this, we should see that the UI here in this case, so what we're going to do is we're going to introduce two versions of the UI, and one version is going to talk directly to the monolith, and what we want to do is get rid of the UI from the monolith. So we're going to actually make a change to the monolith, rip out the UI, and make a new deployment of the back end, right? So we're going to have a UI that talks to the monolith, and then we're going to have a UI that talks to the back end, but we want to slowly shift traffic over. We don't want to make this a big bang change. So to do that, what we're going to do is, can you guys see that okay? Oh, come on. Wait, that's not what I'm expecting. Okay, that's better. So what we have here is we have our backend, we have our monolith, and we have one version of the UI. And this UI talks directly to the monolith. What we're going to do is introduce a version 2 of the UI that talks to a backend service, not directly to the monolith. So if we come up here, all right. So the first thing we're going to do is we're going to use Istio to control the traffic. We're going to say all of the traffic destined for the UI service, in this case, a Kubernetes service, will go to version 1 of the UI. So any traffic coming in will always go to version 1. Now, if we do that, let's apply that. Cross fingers. One second. Oh, come on. Everything's hanging. This is not good luck. I don't know if anyone's in the previous talk that I did. That demo crashed too. Damn it. All right. I don't know. The cluster seems hosed.